Okay, Year 11 mock exam question 4. Electrolysis question. Explain why electrolysis would not take place in the apparatus. We have solid zinc chloride. So since it's solid, what can we say? Well, in a solid, the ions, and we're not talking about electrons, it's really important. This is ions. Electrons, we're already talking in metallic structure. Okay, so in a solid, the ions are not. We got two key phrases here. Free to move is the first key phrase, and carry charge. So they are not free to move and carry charge. They can't do either. So that's 2 marks there. But these key phrases are really important. Free to move, carry charge. Nothing to do with electrons, it's to do with the ions. Next question. Explain why graphite conducts electricity. Now, it's actually very technical, this question, and you have to be very precise in the way you answer it to get the full marks. First of all, we're going to say each carbon forms 3 covalent bonds with other carbon atoms. 1 mark. Next, we need to talk about the fact that we've got an electron spare, but we have to say that each carbon atom has 1 electron left over or unbonded, which becomes delocalized. Delocalized keyword, and saying it's each carbon atom. So many people just said that it has electrons that are delocalized. That was not enough for the mark scheme. For the mark scheme, you needed to say that there was 1 electron per carbon being delocalized. You could also say at the end that that's already 3 marks because you've got 1 mark for saying each carbon atom 1 electron, and these electrons becomes delocalized. But for completeness, we can also say the electrons carry charge. You cannot say the graphite conducts electricity. It's already said that in the question anyway. We've got to say why. And the explanation is always the electrons carry charge. And really, to make that complete, we should say across the entire structure. Right, question 4.3. Student made error in selecting the apparatus. Okay, we've got the apparatus here. We've got 2 upside down test tubes. We've got the electrolysis set up, which looks all correct. We've got a power supply. It's DC. That's fine. We don't want AC. Some people got confused about that. You know, it's a DC power supply, like a battery or a power pack. We've got 2 graphite electrodes, which is fine. The electrodes don't need to be different metals. They can be graphite. And we've got a sodium chloride solution, which is fine because we can electrolyze that electrolyte. And we're collecting hydrogen and chlorine. But the investigation says a student wanting to investigate how the volume, and this is where highlighting and underlining key terms in the question is really important. We want to find the volume of gases. Does this find the volume? No, it just shows gases are being produced. So, very, very simple. There are a couple of ways to answer this. I'm going to go for the obvious way. I'm going to say test tubes can't measure volume, which is the problem. Replace them with, now you've got two choices here. You can use a gas syringe, but I'm going to go for the simple with upside down measuring cylinders. And it shouldn't surprise anybody that measuring cylinders is a technical term. You cannot get away with saying measuring jugs or anything like that. You need to say cylinders. Question 4.4. Describe the trend in the results. Now, this was a very difficult question for people. It should not be difficult because we need to have this key vocabulary. And the key vocabulary I'm talking about is directly proportional. So when a graph goes through 0, 0 and has a gradient that is constant, it is directly proportional. Using terms like linear or straight is not acceptable. We need to use the key term directly proportional. So for the first one, we can see that the production of hydrogen with time is directly proportional. So we can write that down. For hydrogen, the production of I shouldn't rather say production, we'll say the volume. We use the exact things it says on here. The volume of gas produced Little tip whenever you're talking about graphs, always basically write what's on the axis. The volume of gas produced in centimeters cubed is, and here's our keyword, directly proportional. Proportional itself isn't enough. Directly proportional. Directly proportional is a term that comes up in all three sciences. Very important to use it. So directly proportional to time. And the time is in minutes. Remember, M is not a shortening for minutes. We have to write min. Now, we've got a couple of approaches to get the rest of the marks. You can actually get a mark now for working out the rate. You didn't have to work out the rate to get the 4 marks, but it's very easy to do. And they've given you a graph, and you can see that in 20 minutes, we produce 9 centimeters cubed. So our rate is 9 divided by 20. So we can pop that into the calculator and get 0.45, and you've got to have the unit correct, centimeters cubed per minute. Now let's talk about the chlorine. So for chlorine, what's happening? Well, for chlorine, it's not linear for the first what? Well, we can see that the straight line begins at 8. So for the first 8 minutes, chlorine is produced. So the volume increases. Okay. But not directly proportional. You can also say that for the first minute, the rate increases. Both of those would be fine. And then after 8 minutes, the rate, again, rate's the really important word, the rate of chlorine production is the same as for hydrogen. And you can also, again, say it's directly proportional. I've written quite a lot there for 3 marks. That's because there are actually lots of different ways to get the mark. But the important thing is that term, directly proportional. So you didn't have to work out the rate in terms of the of 9 divided by 20, but you could have got a mark for that, but you didn't have to put that down. You can just go straight for that the hydrogen production is directly proportional, and the chlorine is, the rate increases, but then after 8 minutes. And 8 minutes is the important thing. 8 minutes is stated. You have to be able to read off the graph that it's 8 minutes. That after 8 minutes, the rate of chlorine production is directly proportional or the same as the rate for hydrogen because the gradient is the same. So why is this happening? So this was a tough question. Lots of people wouldn't be able to answer this. And it requires just a little bit of a kind of a leap. It's quite a high demand question. It's just one reason why the difference in volume for each gas collected. It's simply that the chlorine initially dissolves in the water. And that's all. Again, not an easy one to remember, that one. Okay, question 4.6, we've got a straight calculation question. Calculate the amount in moles of chlorine collected after 20 minutes. So first of all, we're given this number you should try and remember, 24, but you've been given it because it's a low demand question. And we know that 1 mole of gas is 24 decimeters cubed. Decimeters cubed is not, however, what this graph is measuring. It's measuring in centimeters cubed. So we get a first mark here for simply reading from the graph. I'm going to put my annotation on the graph. You could do it with a ruler. It's important to annotate this and know that each small square is going to be 0.2 because that's 7. So this is going to be 6.6. So our first mark is simply for saying that there's 6.6 centimeters cubed of chlorine produced. But now we need to turn that into decimeters cubed. So 6.6 divided by 1,000 equals, let's put this in the calculator, 6.6 divided by 1,000. You could do this in your head. You could just bounce the decimal place, but I'd always recommend double checking with the calculator. You don't want to make a mistake like that. Putting 1 too many zeros in, or 1 too few. And now we've done that, we can just work out what fraction of a mole it is by doing 0.0066 divided by 24. And that gets us the answer of 0.000275. Now the question has said, give your answer in standard form. I haven't given my answer in standard form yet. Actually, that's important. Don't give your answer in standard form until the end. Make sure you've written out the answer in normal form first. Now we can work out standard form. I'm going to use my very simple bouncing technique of bouncing the decimal place. 1, 2, 3, 4. And it's going in this direction, so it's minus. So it's 2.75 times 10 to the minus 4. And we're going back 4 places, so it's minus 4. Remember, good standard form always only takes the decimal place after the first number.